Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to apply Newton's laws for general plane motion. In this example, what we're looking at here is this truck. It's got a center of gravity G. It's moving to the right with some speed. And imagine that a deer or something comes walking out in front of him. Driver slams on the brakes. However, his front brakes are not working in this example. So what we're going to try to do is calculate the best acceleration or best rate that this truck can slow its speed, assuming rear brakes only. Right? There's going to be no front brakes in this problem. So we're going to want to draw ourselves a free body as usual. First force I tend to want to put into my free bodies is the gravitational force. So in this example, the gravitational force is down, right, mg. We've got a pair of normals, one at the back tire, one at the front tire. So I'm going to put a normal up. There's my normal at the back tire. We've got another normal over here at the front tire. Not worrying about the relative lengths of them right now. Now, if this truck is braking, then we're going to have a frictional force applied, and only the back brakes are working. Poor driver. So we're going to have one frictional force applied at the back. Now, when problems get reasonably complex, again, you always draw the first picture showing all the forces, then you draw the kinetic picture, or what I sometimes call the inertial picture. Let's see, we can do that either here, or actually let's do it here, where you show things like the MAs and the I alphas. So there's my second term. In this example, the MA for the truck is going to point left. Whoops. All right, MA. We don't believe the truck is going to tip end over end, so we're not going to put an I alpha term on, and there's no acceleration in the Y direction. So there's what the free body looks like, and there's my MA term. Now we start writing equations. Equation 1. Sum of all forces x direction equals MA, and my standard rule of thumb, identify the acceleration direction, call that positive. So from my picture, the acceleration of this truck is from the left, and let me talk more about where that came from. The truck's velocity vector is to the right, but if he's applying brakes, the velocity is decreasing with time. So the acceleration points left. That's where that's coming from. So summing forces x direction equals MA. We take a look at our free body here. Only one force in the x direction, F, and then equals MA. And right next to it, I'm going to go ahead and write this one, that the frictional force is equal to the coefficient of friction times the normal force. It's important to realize in this example, it's the back normal that's important. The front normal is not mattering at all. All right, second equation we can write, sum of all forces y direction equals 0. This is not accelerating up, so that's going to give us the equation that the back normal, let's see, plus the front normal minus mg equals 0. All right, next equation we want to write is a torque equation. I'm going to go ahead and write this over here, and we have to choose where to sum torques about. I'm going to go ahead and pick this point right here. Why not? So sum of all torques, and I'm going to just say this, about my red dot, which there's my red dot. Sum of all torques equals, not 0. Sum of all torques would equal 0 if we summed a torque about G. But again, the red dot, that red dot in my picture on the right is over here, and this MA produces torque about this point. All right, so before we even write this equation, we got to talk some geometry here. Let's see, this is some distance here, and just like in my previous example, I think, I'm going to do the distances in black, and I'm going to go ahead and call this distance x1. Then we've got some sort of horizontal distance to G here. Call that one x2. G is some distance from the ground. I'm going to go ahead and call that one y. So now when we sum torques about the red dot, what we're going to get is ma times y if we do counterclockwise positive, because I'm doing the right hand side first. When I look at the right hand side, this ma is pointing left, but that produces a counterclockwise moment about the red dot, and I'm calling counterclockwise positive. So if we sum torques about the red dot, that's going to equal ma times y. Now that's ma times y, not a sub y in this example. So summing torques about the red dot, looking at this picture, this normal at the front does not produce any torque about the red dot, so we're good, we're fine there. The force mg does, so we're going to have mg times the distance I have labeled as x2, and that moment term is positive because mg is producing counterclockwise moment about my red dot here. All right, so that one's done. Frictional force goes right through that point, we don't need to worry about that. The back normal, however, is producing moment or torque about this point. So we're going to have minus back normal times the distance x1 plus x2. That's coming from the fact that this force x all along this line. The torque arm for that force is this distance. That's what I've got it labeled as. Also notice this force right here is producing clockwise moment about that point. I've got counterclockwise positive, hence the minus sign. And then equals, right hand side, ma, and I'm going to put that in parentheses, times y. Again, that's not ma sub y, that's ma times y. So here's our system of equations here. The next step would be to solve this system of equations. If we kind of glance it over, it's got three unknowns, front normal, back normal, if we look right here, and the acceleration of the system. But we have three equations to solve it, 1, 2, 3, because this equation right here, I can rewrite it easy enough. Coefficient of friction times the back normal equals ma. So now comparing, and I'm going to do these in green, this equation, and this equation, and counting unknowns, back normal, acceleration. Look over here now, we got front normal, acceleration, back normal, and that's it. So the three unknowns in this, in theory, are going to be the back normal, the front normal, and the acceleration of the system. And it's three equations, three unknowns, and I'm not going to bother solving it. The purpose of this video is just how you write the equations. At some point I'll get a numerical example in where I'll solve it right to the end. But hope this video helps with how to write the equations and with how to draw the free bodies, including the kinetic part, the MA part, and then use your free bodies to write a system of equations for general plane motion. In this case, 2 force and 1 torque equation. Have a great day.